So we're going to attempt a demo at the end of this session. So give me a second to get set up. And of course, the law of demos, the number of people in this room, the chances of it working is pretty low. But we'll see. We'll see how this goes.
Inverse proportionate. So you guys have a good conference? Yeah? These guys worked really hard to put this together. So while Paul's setting up, just a little bit of background. We'll talk a little bit about the brief history of AR, VR, XR at Boeing. We have a long history with this stuff at Boeing. We heard from the father of VR yesterday and AR arguably, and he worked with some of our guys way early on back in the 90s. And actually, one of our guys, Dr. Tom Caudell, coined the term augmented reality. So it's kind of a cool deal for me to actually meet one of my heroes here yesterday. Did you guys get to go to his presentation last night, anybody? It's pretty amazing. So we'll talk about that a little bit. So here we go.
All right, great, thanks. So I'm going to kick off with a few intro slides and then hand it over to Brian. So again, I'm Paul Davies. I'm an Associate Tech Fellow based actually in Los Angeles, drove down here. It was really easy for me to get here. Topic today I'm going to talk about is called Time to Get Real Applications from Mixed Reality in the Real World. So Brian, myself, and the rest of our team, we actually have a really great team across the whole company now working on these things. We've been focused on this space personally in manufacturing, but we're also using it for design reviews, training, other things as well. So I'm going to share with you kind of a little bit of our story, starting out using tablets. You'll see some examples of our augmented reality tool that we've developed, where we put it, which programs, what we're doing with it. And then more recently, our work with some wearables, including the HoloLens. And then, like I said, at the end, we're going to try a demo. So I always like to start out with some definitions. And of course, this crowd is very well versed in this, but when we talk to folks at Boeing, we've tried to standardize some terms, and they're only internal to Boeing. These terms are what we've kind of settled on inside the company, because there really is no standard. There's no way outside, in the industry, there doesn't seem to be much consistency. So we've tried to set some terms. So virtual reality, pretty obvious, immersed in a virtual world. One that we call informed reality would be something like Google Glass or the Vuzix displays that are just information snacking, where you have a small piece of information not spatially registered to the world, but is still on a wearable. Augmented reality, we'll talk a lot about that today, is where content is spatially registered to the world, and then mixed reality is very similar to augmented reality, except you handle real-time occlusions. So that really is the closest you can get to a true mixed reality experience. So inside the company, we try to use these terms and try to keep everyone on the same page. Now, there's a lot of confusion with our leadership and other companies, I assume, in what augmented reality is. So I try to be very specific on what it is and what it maybe more importantly, what it's not, and which devices can do augmented reality. And there's actually only a couple. So of all the things that come on the market, and there's more and more every week, every month now, there's new companies producing hardware. There's actually only a few of them that can do true AR, and I've circled them here. So of course, tablets and cell phones, we're going to talk about those today. HoloLens, DAQRI, things like the Meta display and the ODG are some of the examples that can do true AR. Google Glass, according to our definitions, is not an AR device. Vuzix, informed reality, not AR devices because they have trouble aligning things into the world. And of course, VR, Oculus, HTC, Vive, things like that, just in a different space. So it's kind of interesting. Brian likes this slide, 20 years ago. We were all being yelled at not to sit too close to the screen, and now, of course, the closer the screen, the wider the field of view is a good thing. So,
anybody identify? Hands? Yeah.
So we have actually a long history, and in fact, we believe Boeing actually coined the term augmented reality in the late 80s when two of our researchers, Brian mentioned, Tom Caudell and Dave Mizell, worked up in Everett Wire Shop for commercial airplanes, put together this prototype. You can see this display he's wearing on his head, those dots on the board for tracking, and he's seeing very basic 2D overlays that guide the illustration of buildup of harnesses. Now, this is way before its time. The industry wasn't ready, culture, we weren't ready, but going back 30 plus years, we've been working on this space. Now, so moving forward, fast forward to today, we've done a lot of work trying to understand where AR best fits in production facilities and manufacturing so we can get the most benefits out of it. And we've identified a number of criteria that we believe using AR to deliver work instructions can impact. And these are the things we're trying to capitalize on in our production line. So reduction in assembly errors, reduce training requirements, reduce assembly time, help people remember work instructions more accurately, and then, of course, we'll talk about tribal knowledge and how we transfer that to the new generation of workers. And all of these things come together to do two really good things for any manufacturer, and that is to decrease the manufacturing cost and increase the first-time quality of the build. So two of these things we really focused on and honed in on is the reduction in the assembly time and the reduction in errors. Higher quality, built in a faster time. Those are two really powerful things for us. So to that end, we wanted to know how impactful AR could be. So we did a study a couple of years ago, and I've presented this more than once or twice. So I apologize if you've seen this before. This has been published at ITSEC. You can download the full paper that explains how we did the study. But essentially, we brought in around 50 people, and we gave them different ways of receiving work instructions to build the same assembly. People either used a desktop computer, had a 2D PDF document on a desktop, they had the same document on a tablet so they could just see it close to the build, or they used our prototype augmented reality tool with, again, the same steps, the same instructions, but now we're using AR to deliver them. And everyone built the assembly twice using the same mode. So if you were assigned desktop, you'd built it once, we took it apart, you'd build it again, and then you do it twice. So here's one person using our tool. This is an earlier version of the tool, and you can see it's got an animated overlay showing her how that piece goes in. And that's kind of one of the tricky pieces because it has to go in at an angle and rotate to get it to fit properly. You can see she's wearing a helmet. That's just so we can track her location in the work cell. We know how much time she spent looking at the instructions or at the workpiece or anything like that. And now she's turned it around. She's looking at the parts bin, and then there's an overlay that's showing to take 6 of those pieces from the top rack and 6 from the third one down. So she'll go pick those up, and then all the instructions are there on the right-hand side, you can see, and then when she hits the next task button, the system will show her where to point the tablet for the next step, the location of the instruction, and then she'll go over there and do it. So I'll just let this next one play here for a second. And so now the arrows come up, and now it's saying look toward the wing, and now the pieces she just picked up are being shown how they should be installed. So what we found was we timed and graded everyone, and then we found that the number of errors went down drastically when we used augmented reality as compared to the other modes. And these are people that have never used AR before, never probably even heard of AR, and certainly never seen the assembly before. So they're brand new people to doing this job. And augmented reality came to be the best. Of course, the first build, there was around half an error median, and the second build, nobody made any mistakes building it. And then when we looked at the time to assemble, that also went down. AR was the fastest mode of instruction. And when you compare the worst case, which was the desktop, to the best case, it results in around a 90% improvement in quality and a 30% reduction in the cycle time. And these are, of course, optimal numbers for someone who's never seen the assembly before in a controlled environment. So we're not claiming these are the kind of figures that we'll see, but even a fraction of those would be really impactful for us. It's not all good news, though, because to do this kind of stuff in an industrial environment, there's a lot of challenges. Touched earlier on policy issues around cameras and security. There's comments about having cameras on the shop floor. Availability of content is tricky. A lot of programs are not designing or not laying out work instructions with AR in mind. So is there really content that we can maximize this stuff? How do we interface it with legacy systems, regulatory issues, FAA regulating how we deliver work instructions and do inspections and things like that. Cultural readiness, are people willing to wear head-mounted displays along with safety and ergonomics? So there's a lot of work to do, but of course we believe the potential is there. So I have a few examples of some of the things we are doing today. This is our current standard for AR for work instruction delivery in the factory, and we've got 5 of these systems now that are installed here in LA, up in Seattle, and in St. Louis, and in Philadelphia. They're all over the company. And it's tablet-based, so we kind of sidestepped any wearable, ergonomic, or safety, or any operating systems that aren't Windows or the enterprise version of Windows. We kind of sidestepped all those challenges, and we said, we know tablets aren't optimized for delivering this stuff, but we can do it today. So that's what we focused on today. Tablet goes on an arm, so you don't have to hold it the whole time, and you can wheel it around. And then we install these tracking cameras around the volume. These are made by Vicon. And that gives us really reliable, accurate tracking. So we can do AR in large volumes, like as big as this room, and have accuracy down to like 1/8 of an inch or better, which is good enough for most of our use cases. In the future, we're already developing an application that's going to be able to be deployed to different platforms, because the message here is that there is no one platform that fits all use cases. If we're in a confined space, probably a cell phone might be a good solution. If we're in, a hazardous environment, maybe a Daiquiri helmet that has other sensors that can, protect the worker in certain situations. Sometimes a tablet is the best solution, but there's no one size fits all. And they all have pluses and minuses. When we look at cost, the robustness, the accuracy, things like that. So we're trying to develop a common application that will be owned by IT, deployed by IT to programs who want to use AR, and it can be deployed on different platforms depending on the use case. And that's what we're working on today. I got one example here, and I'm going to hand over to Brian. This is one of our training applications on the HoloLens, and this is what I'm going to demonstrate
This is the
toward
aft
the
lower
end.
door sill installation. These are the parts that should come in your kit for installation. The forward clip, the aft clip, 2 CFRP fillers, the CFRP cord, and the sill web.
So this goes on
The aft
for
lower door sill
a few minutes.
installation is
And
installed in the lower right cargo area of the aft join between station 1593.
essentially, the
Station
person who's
1618.
learning this job knows nothing
Word of
about it.
caution.
And through a
Do not
combination
use a
of
HEPA
spatially
vaccine
registered
by
models,
drilling
the
operations, as
tribal
fire
knowledge
could
through the
result.
audio, the
Use a
text,
tiger bat, or
we
let
believe
the
that it's going to help them to learn the job faster
then
and help them to remember it better too.
Have a titanium
So we
fire
tried this on one job on the
breach
787 program. We're looking at rolling this out to other jobs as well.
Use during the
And I'll show you a demo of this at the end live. Part of this, we modeled a bunch of 3D tooling, clamps, drills, feeler gauges, and because it really is just a matter of, I see it, I do it. There's no room for any errors or confusion about what to do.
Generations of talented Boeing employees help build the world's largest.
So next we're going to talk a little bit about digital aviation. We're doing some work with training for not only FAA certifications to repair and to maintain our airplanes. We're also looking at ways to apply things like VR to pilot training. We have an advanced age workforce. Most people that have union type workforces will find that you end up with kind of this massive bubble right now where you have a lot of folks that tend to be older, more advanced in age, because the lower seniority folks tend to get laid off time and time again as you go through a series of layoffs and things like that. So as you can imagine, it's somewhat of a problem. This is also in the aviation industry in terms of pilots and whatnot. So one of the big issues that we're going to be facing here very quickly is we're going to run out of pilots to fly all these planes. Right? So we're continuing to purchase airplanes, we're improving the airplanes, all these kind of things, but we won't have any people to fly them. Training a pilot is a very expensive endeavor. It costs on the average about $1,500 an hour for full motion sim time. And so one of the things that we found is that through the use of VR, we can reduce up to about 70% of the cost of training a new pilot with the higher fidelity VR simulation software that's out there, and we're actually developing some that's going to be the highest yet. We can actually reduce the on-plane time and on full motion sim time, which dramatically cuts the cost. Go ahead and cue up the video. So this is a little thing about training how to do the airplane repairs. We'll go ahead and play this little video and show you guys. If you could restart that, it'd be great.
Space company and shape the course of history along the way. For the past 50 years, Boeing Flight Services has trained the world's best pilots and the best technicians. However, as our aircraft designs and products continue to evolve, so too must our training.
Our customers have given us feedback about our current training methods. Some of their biggest pain points are airplane access, class duration time, and training cost. I'm here to tell you we hear you.
We envision a new world for airplane maintenance, a world beyond traditional simulation and training, classrooms without walls, and a place of learning and in-service support that's founded upon collaboration and designed for continual improvement, for more effective training and improved turn time through better training that's both more affordable and more accessible for generations to come.
HoloLens allows us to address these issues by bringing the airplane into the classroom. This lets us teach theory and practical training in a realistic environment in a more effective and engaging way, ensuring that our students leave more prepared to do their jobs.
Boeing continues its journey of exploring the use of technologies for improving airplane maintenance training and in-service support with Microsoft's HoloLens.
Our airplanes are getting much more sophisticated. They can collect and report a lot of information about faults that may occur. With the HoloLens, the aircraft mechanics can refresh their knowledge about how to address these issues.
By using real-time fault reporting combined with electronic logbook, maintenance operations are able to pre-position critical resources such as parts, tools, and mechanics, provide just-in-time training to key personnel, and collaborate with subject matter experts to swiftly resolve in-service issues and reduce turn time.
By utilizing some of the latest technologies like HoloLens, we can transform the industry and deliver superior products to our customers. This dynamic approach propels Boeing into the next 100 years of...
So what we just saw there, it looks like a lot of movie magic in there. Some of it's a little bit scripted, but we'll show you a live demo here at the end with the 737, the nose landing gear. And Paul or I will actually control the thing, voice activated up and down, and it'll be one-to-one scale. We'll have it set up so that you can actually see what we're seeing, first-person view, and it'll be floating here on the stage with us. So pretty cool stuff. What you're seeing here now is a thing called HoloPort, and we're actually doing some preliminary work with Microsoft in this space. What HoloPort will allow you to do is to create true holographic images where Paul and I, for example, could each have these headsets on. Paul could be in Spain, I could be in England, for example, and we could actually have a conversation. It would look like we were standing here on the stage as we're standing next to each other. I would be able to see Paul as if he was standing there, and he would see me, and we could do it in a group of folks as well. So lots of very powerful technology coming this way. One of the things that I really appreciate that I've heard time and time again, as wow factor as this stuff is that it's most important to match the need to the technology. Not everything needs to have this level of fidelity and these kind of wow factor type technologies applied. We're doing things with, you heard earlier we talked about tablets. We're doing things with Google Glass. You might have seen the Harvard Business Review article. We run the gamut. And the point of all this stuff is to not think that there's a one-size-fits-all type application. You have to make sure that you understand what it is you're trying to accomplish with this. What's the soul of the intention? I can't impress that enough. Next slide. Maybe I can do it. Oh, there we go. Okay, design review. So one of the things that we found has been very helpful with HoloLens is that it enables us to do engineering design reviews in ways we've never been able to accomplish before. So if you could click on that top video there.
I'll just start at the bottom and I'll pan up.
So with the International Space Station,
open doors.
We had some issues with one of the water tanks that we were trying to figure out, how we were going to put this in there and whatnot. We actually had our chief engineer was at odds with his staff, and he thought that there was plenty of room, and his staff said, wait a minute, we can't do this, we need to stop and reconsider. And he said, no, I don't see the problem, go forward. And we ended up putting that model on a HoloLens, put it on the chief engineer. Within about 15 to 20 minutes of him kind of looking around at the model, he figured out that indeed there was going to be a cooling issue, and they didn't have enough space in the rack. So with that particular instance, we say probably 2 design cycles of iteration, which is really expensive when we're talking about space and aircraft type design. In the second one, if you click the second video there. So you guys might have heard of the Starliner. This is actually the model for the pod. The neat thing about this is we can actually take the actual CATIA engineering drawings and visualize these things, put these on an engineer, put them on a customer, an astronaut. We actually do this quite often. Chris Ferguson, the 8th Space Shuttle Mission Commander, has been one of the guys we've been working with on some of these things. And they can walk through these models and they can actually see ergonomically, how's this thing going to fit them? And you actually see the guy walks through the back of the module, he'll put his hand down where the controls are, and you can kind of see how this thing might work out for the astronaut and where the controls are placed and what the configuration is, so we can find very early in the design process where these issues that might hang us up would be. So we'll let that run for a second. So I don't know, it'd be interesting, we'll have a little bit of discussion afterwards, but how many of you guys have found issues where one of the things we hear about HoloLens is, it's not immersive, and they complain about that. And if you look, you can see some of the stuff through the background. Can you guys see that? Where this is filmed in an office? So the interesting thing is about the way that we work attentionally is when you get somebody into this environment and they become immersed in the experience, all that stuff fades away, right? It's pretty interesting. And you guys have witnessed this time and again where, you get really focused on some kind of a task and you end up making mistakes or you realize that, you blew by your exit because you were too busy singing with the radio or whatever it was you're doing. So it's really interesting. There's a lot of kind kind of armchair critics that have a lot of things to say about a lot of this technology that don't really have the experience to back up the kind of things that they suppose. The best advice I could give on any of this stuff is to go out and find out. You know, in God we trust, others bring data. So go out and actually test these kind of things and figure out what really works for you. And the other thing is don't do this to or for your end users, do it with your end users. The big head fake that IT often misses is we think that we can outguess what our end users need. And two things, if you keep your end user at your hip the entire time that you're developing, not only will it be their baby, they'll have ownership in the thing, but there's no way that you can miss because you're continually changing the direction as you go through the development process. Next slide, please. So this is a floor layout tool. One of the things that we run into a lot is these airplanes are really big, you know, they're massive. And so when we have to lay out a new shop or an area for these airplanes to move around, and it can be really cumbersome. So if you can click on the little video. What this tool does is, when it comes up, it's a layout tool. So we can actually go into a laptop, and you can lay out your tool using this particular application that we've created, and you can get it, you know, roughly approximated as to how you'd like to see things in there. The really cool thing about this is once you save that, you can go ahead and put on a HoloLens headset and turn around and walk through the model that you just created. It's really amazing. The guy yesterday, he showed a little bit, they were doing some things with concrete. This is very similar type application. The coolest thing about this isn't an artist rendition, none of that type of stuff. This is actually, you know, when you get done building this stuff, a lot of times the things we're using where the airplanes are concerned, it's actually the CATIA models. It's the true engineering of the plane. In the past, we've done a lot of work with other kind of design firms and things like that, and we still do. But we're trying to move away from kind of artist renditions of things and go back to the true engineering because it shortcuts that design cycle process. So next slide, please. So we've been talking about HoloLenses and tablets and recons and all these different kinds of advanced visualization tools. Kind of the elephant in the room, if you think about it though, is how do you get these things to talk to each other? Because quite frankly, as powerful as the visualization tools are, they're not the end all be all, right? It's just a vertical. We have data analytics, and we heard earlier about IoT, we have Internet of Things, we have cloud computing, we have additive manufacturing. So the real magic I'd suggest is when you can link all these things together and they can be conversant, and you can start to use these as a system of systems type approach. So one of the things that we're doing to address that, I'm a tech fellow for Boeing and a tech focal for Carnegie Mellon. We did a capstone project. We took about 5 master's level HCI students out in the factory. We spent over about 8 months doing the capstone, about 4 weeks out on the factory floor at the hip of the engineers, the inspectors, the mechanics on the factory floor, learning firsthand not what technologies they're wanting to deal with, but what kind of information do they need in order to complete their job correctly. So what we found was they needed basically 3 things. They needed access to authoritative documents and files, PS, DS, readars, things like that. They needed to have ties into the MES system of choice, manufacturing execution system, so clock on and off the job, look at work instructions, things like that. We demonstrated that earlier with Paul's application. And the third thing was they needed to have remote assist capability, so they could call in, phone a friend, so to speak. They could talk to that engineer, that shop lead, whoever they needed to get help to fix the problem at hand. So what came out of that was a project that we call Echo. Go ahead and run the video, a little 2-minute video. And this shows kind of how this concept might work.
Hi, I'm Jim.
It's a little cheesy.
I'm a wheel well mechanic, and I've been working at Boeing for a long time. I'm good at my job, but occasionally I run into a problem that will slow down production. When that happens, I have to leave my work area and search around for someone to help. Most of the time, I'm looking for my team lead, Monica. After my team lead diagnoses the problem, she has to go tell the barge and tell them the same thing that I told her. Then, there's also the need to get the people from upstairs involved. We have to send someone all the way up there, interrupt their work, and explain the whole thing to them again. This process is frustrating and can go on for days. It's also frustrating when I can't access information when I really need it, like when I'm working inside the wheel well. So I have to walk back and forth to a computer station several times a day. Thankfully, my flow day started to use a mobile and desktop tool called Echo, and I'm already starting to like it. With Echo, I can notify my team lead without leaving my work area or chase anybody down. She gets a notification on her device and knows that I need her help. My team lead can also use her Echo device to video stream my problem to other people at Boeing. This means I get real-time help on my issue without having to run around to find people. More people can be added to the video call even if they're far away from the plane. I'm glad that I can reach them so easily. But guess what? Echo is more than a communication tool. I can also use it to quickly look up information on my task, update my work status, start jobs, and buy them off. This saves me a ton of time throughout the day and reduces my risk of injury. My shift just ended, so I'm going to stop here.
So
but hey, I got to tell you.
the point of this is point of use and time of need information. And like I was saying earlier, this is an example of how we can leverage this kind of an approach. And Echo is, again, looking to tie together all these different things, this Internet of Things, data analytics, cloud, all these different kind of aspects of our enterprise that today are largely talked about in silos. And unless and until we can get those things to interconnect, we're never going to be able to unleash the power of what these things have to offer. So next slide. So one of the ways that we could use this, I'll walk you through a scenario. This is kind of an arcatine. The airplane's flying in the air. We have some kind of an issue with an engine. You see the little picture of the engine there, and it's actually tagged. So it has sensors on it. It's Internet of Things. Sends the information up to the cloud. The cloud does the data analytics on it and says, what's going on here? And so it has this conversation back and forth with the plane. Says what other systems are going on, what's affected, what are the different symptoms of what's happening? How does that compare to experiences we've had in the past? Comes up with what it thinks the solutions are. It can actually Pareto rank these things in a listed order, sends the information down through Echo to the headset, to the mechanic who's actually has that fan cowl popped open with the airplane when it lands. Also, it checks and it says, I noticed that I need this part for the fan cowl. Well, do I have one on hand? And so it checks the inventory. Well, it doesn't seem to have one on hand. Do I have a 3D printer locally that could print that thing? I do. Great. Sends the instructions, 3D prints the item, sends it over to the mechanic who's waiting for it. We get the plane turned around. By the way, and this is in Frontiers Magazine, it's public knowledge, a AOG condition, which means airplane on ground, costs our customers between $10,000 and upwards of $150,000 an hour. I'm gonna let that sink in for just a moment. It's a lot of money, right? So with this kind of an application and this kind of a systems type approach, we can actually turn those planes faster and get those things back in the air and keep our planes flying longer and in a safer and more efficient manner. Next slide, please. So with that, we're going to go ahead and show you a couple things at the demo and see what you guys think.
All right. Are we able to put this up on the projector? All right, there we go. All right, so you guys are seeing what I'm seeing. There's about a 5-second delay, so when I put my hand up and do things in front of the camera, you have a little bit of a delay. So I've got two demos for you. One is this is the training application that we're trying on or we piloted on the 787. So I've already launched it, and when I look up here, it's showing me the home screen. So this is where I would pick whatever job I'm about to work on. So I'm going to choose the second version of the door sill installation, and say next.
This is the app lower door sill installation. These are the parts that should come in your kit for installation.
This is the app lower door sill installation.
You guys hear it?
These are the parts that should come in your kit for installation. The forward clip, the aft clip, 2 CFRP fillers, the CFRP cord, and the sill web. The aft lower door sill installation.
And we can just turn the volume down for just a second.
Area of the aft joint.
So what I'm looking at here, I've got some controls at the top. I can move the canvas around if the canvas is not in the right place. I would align this content to the airplane using a marker originally. Right now we're actually working on a better way to do that, but we haven't released that yet. And then up here I've got some options. Down here I can move to the next task or the previous task, and then I've got my instructions here. So the 3D content, the 2D text, and the audio all combined are what's going to enhance the rate of learning. So I can move around. Obviously, you've all tried the HoloLens probably, and if I want to see how this looks from a certain angle, I just go look. And when I'm ready to move on to the next step, I just go to the next arrow. And so I can see my next step here is to locate this Cleco. And I guess the red arrows show me the Cleco locations. So I can go in here. I can see exactly where those two Clecos need to go. So this goes on for about 45 steps. It takes a couple hours to learn the whole job, but I just want to give you an idea of some of the things we're doing with this. So I'm going to close this down and hand it over to you, Brian, and you can do your the 737 app.
So one of the things is, while Paul's said, why don't you go ahead and just run it, Paul,
Okay.
if you want to. So next we're going to show you the 737 nose landing gear that you saw in the little video clip. One of the things I want to explain that's really important about augmented reality versus anything we've ever had from an interface before, clear back to when we were drawing in the dirt with sticks, right? Everything else up to this date has been an also-ran. It's been information that's external to what we're trying to do. The reason why this is important is because it takes cognitive resources away from us. Here's the way that it goes. I'm going to break it down. I'm doing a job. I have to look at the information that I want to work with, take a mental snapshot of that, direct my attention to the job at hand, basically project that image onto the work, and then solve the problem that I was there for. The process of taking that snapshot and redirecting my attention takes over half of the mental capacity that most of us have to work that problem. So now I have less than 50% to go and actually address the problem at hand. And usually it's much greater than that, especially if it's a highly technical problem, right? So with HoloLens and with augmented reality, mixed reality, all the different realities like that actually do a digital overlay of the project, or the digital asset onto the real world. Can you guys see that? He's looking at the 737 landing gear here. So we can shortcut that whole process by actually taking the digital image and sticking it directly on top of the world. Another way to think about this is you could consider it kind of a time machine of sorts, because I can take an as-is condition and I can put a to-be or even a past condition on top of that condition. I can do a direct comparison. If I'm trying to do this mentally, it's horrifically taxing, right? We just established that. But it also is really inaccurate. There's no structure to this. There's no dimensioning, none of that type of stuff. You want to turn on the rulers?
What's the command for that?
Rulers on.
Routers?
Yeah.
Routers on.
This may be tough. You might have noticed.
Oh, there you go.
Paul's from England.
Gear up.
You see the rulers on the ground. So we can actually dimension this stuff and see what the size of that is. And the reason why we care about that is we can look at how real-world objects might relate to that particular item, if that makes sense.
Gear down.
Now, as good as this is, it's still not perfect. And we heard a little bit yesterday from Tom Furness, the father of AR and VR. And he talked a little bit about some of the visual issues. So there's still a lot of things that we have to solve. But the great thing about this is 80% is great, right? I mean, it doesn't have to be perfect. And that's one of the things that we have to get to also is not only do we have to match the tool to what you're trying to accomplish, but it's really important that we think about, postponed perfection, it is useless next to what I can do right now. And go forward from a point of knowing, not a way of thinking. So get in there, try some things, try storm it, and if things don't happen as you would like, that's called experience, not failure, right? Fail forward, learn from that, do something else. In fact, often we learn more when we have a, quote, failure experience than we do when things go right, because when things go right, there's a lot of reasons why that could happen. When things go wrong, there's usually one or two that have kind of caused it to fail. So anyway, with that, I would hope you guys enjoyed that and be happy to take any questions. Thank you.
Lunch coming up, but I definitely want to leave some time for a few Q&A. You see all the C3 bobbleheads coming, so let's start right here. Please introduce yourself, Vincent, and your organization.
Hey guys, it's Vincent.
Uh-oh.
Southern Nuclear Company. Just a quick question on the Echo. How is that what's being currently used now throughout Boeing? How accessible is it? And as far as the operating system that it operates under on the cell phone piece that you show, which operating system?
So we're the Echo infrastructure, and one thing that's important again is there's space at the table for everybody. This is an OS and device agnostic system, so we're not looking to compete with anything else. The idea behind this is how can we all kind of get everything conversant so that we can use them. We went away from kind of Windows 10, iOS. Can't hear me? Sorry. Is that better? We went away from like Windows 10, iOS, Android, kind of the holy war of the different OSs. And the best thing that we found, and you look at the the increased power of HTML5 and web-based standards, WebRTC, for example, super powerful, right? You can do a lot of things. It's a lightweight data transport protocol. It works really, really well. By going to a standards-based type environment that's open source, you can excuse yourself from the holy war of my device can beat up your device, or let's pick a particular platform. The problem is at some point that thing's going to go by the wayside, and then you have to retool and start over again, basically. And it's called technical debt. And so we're trying to quit kicking that technical debt can down the road, if you will. But that being said, the cool thing about where we're going with this platform-based approach is anything that adheres to the standards that we're setting up, we can use. So we don't care. Bring whatever you want. You want your iOS tablet? Great. If you want your Windows smartphone? Great. If you want your headset that's Android-based? Cool. We don't care. The whole point is how do we get to done? And the other thing is that you notice, because we talk about all these different devices and stuff, we're not interested, again, in that. What we're trying to get to is how do we build an airplane better, faster, and cheaper? So we try to excuse ourselves out of that other and let the requirements from doing due process re-engineering ferret out what the appropriate technology would be. If we're doing pinouts, for example, on a wiring loom, HoloLens or a Google Glass works really great for that, right? If we're trying to do design stuff, like Paul was showing you guys, HoloLens might be your tool. But we're not saying that those are the particular things that you should use. We're saying go and test out what the requirement is and then match the tool to the requirement. A lot of times we start off with this chrome hammer and everything looks like a nail. That's a ridiculous fool's errand. Don't do that. Figure out what you need and then go with that.
A quick interjection. We'll take a couple more questions, but for those that are leaving now to grab some lunch, lunch available, and we will meet back in here at 2:20. So we'll do 2 or 3 more questions.
Anyone want to say, come up right here. Definitely get everyone.
Omar Barkawi, General Dynamics Electric Boat. I was wondering how big your team is. You seem like you have a bunch of cases already. Where did you start? About how long ago? And then how big has your team grown?
Can you hear?
Is this on? Yeah. So I started actually close to a decade ago in this space, and all my work's been in manufacturing. Started out there was about 3 of us back then. Now, we've got teams spanning commercial side, defense side, IT. I'm in the research group across the whole country. I don't know how many people, 50 plus people probably in total. Yeah.
We probably have a core team of maybe 10 to 15, but
in terms of folks in this space, working with these tools.
We have a broad network, and that's one of the really beautiful things. Diversity pretty much always wins, right? Yeah. So we have a saying at Boeing we call One Boeing. We are One Boeing. We actually have people, he's not kidding, all over the U.S. In fact, around the world. We got folks in Australia. So it's awesome. And then the other thing is we reach out to our academic partners. Iowa State University, we're doing things with Carnegie Mellon. There's a lot of amazing work at University of Washington. So there's a lot of work that we rely on our academic partners to help us to leverage their work. Right? What an amazing thing to do your dissertation or your master's thesis on stuff that really matters, not just making things up so that you can satisfy that requirement. So it's a really cool kind of a copacetic, symbiotic relationship that we have. I hope that helps.
Over here.
Yeah, Cal from Practic. Thank you so much for your time. So you mentioned that it's 80% not perfect. So I understand trial and error to improve a product. So what's the error reporting process? Is there any machine learning? How do you improve errors that happen within the augmented and mixed reality?
Do you mean like production errors, like manufacturing errors that were made?
For instance, in the demo you showed us there might be an error or 2. How do you avoid that happening in the future? Is there a way you can report specific errors that you show in augmented reality to improve on your next experience?
No, we haven't gotten that far. We've thought about all those things, and then also the experience of the user maybe needs different levels of instructions and all those kinds, but we haven't really explored that yet. So
but through neural networks, you can have machine learning that you can actually improve just by using the device.
Yes, yeah, we haven't looked at it yet. So,
all right, thank you.
Sure.
It's a good point, and we have implementation plans for those kind of things, but currently what we showed you is what we're actually doing. I hope that's helpful.
It's a starting point.
Yeah.
Sure.
Just a quick question. I just want to understand your experience with using other mechanisms to control heads-up displays. So things like voice, trackpads, and other things. What's your learning in that? Is gesture the best way to go forward, or voice, or?
It's a good question, and unfortunately the answer is almost always it depends, right, what you're trying to do. So in terms of voice, and by the way, the capabilities are all over the place. For example, GoldenEye, right? They have amazing noise reduction capabilities. I mean, you can use that thing standing next to a boat race or a drag race, and it can still understand what you're saying. So it's a complicated answer. Everything depends on what it is you're trying to accomplish. If you need hands-free, then the voice stuff makes a lot of sense. And the gaze tracking, and did you have other?
Well, yeah, I was just going to say that I actually don't think we've even started to understand the true potential and the difficulties in different modes of interaction with head-mounted displays, because you can do gestures, but if you ever used a device for more than 10 minutes, your arms are really starting to get tired. Of course, yeah. I mean, and so we're also used to screens and keyboards. We got it perfected. Now you take away the keyboard, I don't think we've even began to understand really how to interact with computers without keyboards.
I think that a real area of opportunity, in fact, this is my kind of human factorism showing, right, is not to design a better keyboard, but to design a better process that doesn't require a keyboard, right? Why ask you to do something when I can take care of it for you? And that's where the business intelligence kind of stuff and data analytics, where we start to kind of understand more what you're doing. We're at this really interesting crossroad where the computer is moving from being kind of a stupid tool like a wrench or a hammer or whatever to actually being a productive assistant that can proactively offer us things that it notices. We're in the presence of certain tools at a particular time with these work instructions clocked onto a job. Don't ask me what I'm doing. You know what I'm doing, for goodness sakes. That's ridiculous, right? So it's upon us to actually leverage that stuff. And we have to kind of untrain ourselves in many ways to quit being handmaidens to these tools that we created to help us out and let them do their job. I hope that makes sense.
Okay, how about we do one more question, and then we'll break and conversations continue.
Yeah, come talk to us. Yeah, please.
Roland Joseph, Procter & Gamble. I did a quick search for Echo. I'm having trouble finding it. Is that an internal solution you guys developed, or is it something that's available on the open?
No, we gave you a little peek behind the curtain there a little bit. It's a prototype thing that we're working on right now. It's a concept at this point.
It's internal.
Yeah.
But are you looking to market it? Got a go-to-market strategy with it, or are you just going to keep it internal?
We'll see how it goes. We're a firm believer in eating our own dog food, and if it doesn't taste good, then we're not going to be putting it on your plate anytime soon. So it's really important that we do the testing, especially given the criticality of what we deal with. Hope that makes sense.
Okay, very good. I think we'll conclude here.
Thanks, guys.
Thank you very much.
Appreciate it. Thank you.